Hello everybody, welcome to Guidance Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics thermodynamics. We will discuss second law of thermodynamics. We will see two statements. First one, Kelvin and Planck statement. Second one, clausious statement. Please watch the video completely without skipping, and if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you're watching without subscribing my channel, please do subscribe my channel and support me. Please press the bell button and all button near it so that you get intimated as soon as new videos are posted. Thank you very much. Come, let us start the class. Second law of thermodynamics. We have already completed first law of thermodynamics. Now we will pass on to second law of thermodynamics. What is the need for second law of thermodynamics? We will analyze that. First law of thermodynamics speaks about the interconversion of heat and work. What does that law state? What is the mathematical representation? Delta Q is equal to delta U plus delta W. That is, when a certain amount of heat is supplied to a system, part of that heat is utilized to increase the internal energy of the system and part is used for doing work. So as per this law, that is first law of thermodynamics, heat is not wasted. So as per this law, what is the idea that we get? We get the idea that in essence, this first law is the same as conservation of energy. But what happens here? When a heat engine works on the principle of first law of thermodynamics, all the heat that is supplied to that engine is not converted to work done. Efficiency of the heat engine is less than 1. Some amount of heat is wasted. Therefore, all heat supplied is not converted to work done. That is why the efficiency of heat engine is less than 1. We have already seen that. Energy is conserved, of course, but it is not totally converted to work. Some amount of heat is wasted, that is converted to some other form. Okay. The first law of thermodynamics does not speak anything about this energy that is wasted. Moreover, there is another observation. Even though there are concrete examples of cases where heat can be converted to work, there are also cases where heat cannot be converted to work. Of course, without violating the first law. Let me explain it better. There are concrete examples of cases where heat can be converted to work. That is what happens in the case of a heat engine. What else is mentioned here? In nature, in practice, we find that there are cases where heat cannot be converted to work, though it does not violate the first law. Let us take an example for that. Imagine a table on which a book is resting. The table has internal energy. The book also has internal energy. But the table cannot transfer energy into the book so that the book is able to do some work. That is, it is able, in simple terms, it is able to move from one place to another, or say it jumps down from the table. Such a thing is not possible. That is what the second part says. The first law permits or allows heat to be transferred from the table to the book, but it does not happen. So we cannot always follow this first law of thermodynamics everywhere. There is some fact which is preventing this. Scientists considered this and they reasoned. They found out the reason that there is a universal principle which is basic principle which limits or prevents the complete conversion of heat into work. That is, limits the efficiency of the machine or even prevents the conversion of heat into work. In the case of heat engine, the efficiency is limited to less than 1. And in the case of the book resting on the table, conversion of heat into work is prevented. So they argued that there is some basic universal principle which limits these phenomena. This universal basic principle which limits or prevents the complete conversion of heat into work that is, limits the efficiency of the machine or even prevents the conversion of heat into work, is what the second law of thermodynamics says. Now we will see the statement. Different scientists have given this statement differently, each one in their own words. Anyway, in our syllabus, two statements given by scientists are stressed. We will see those statements only. One statement given by Kelvin and Planck, known as Kelvin and Planck statement, and the second one given by Clausius, called Clausius statement. Kelvin and Planck statement. What does it state? It is impossible to construct a heat engine which would absorb heat from a source, that is reservoir, and convert 100% of the heat into work. Now, Clausius statement. Clausius statement says that it is impossible to design a machine unaided by an external agency which would transfer heat from a body at lower temperature to another body at a higher temperature. Both these statements mean the same thing. The first statement speaks about the limitation of the heat engine, whereas the second statement speaks about instruments or gadgets like refrigerators. Both the statements are negative in a sense. How is that? It says it is impossible. It says that something is impossible. It does not suggest a means by which this can be overcome. Let me explain this. The first statement says that there is no means by which we can improve the efficiency of the heat engine and make it 100%. Let me explain the second statement in detail. It is impossible to design a machine which would transfer heat from a body at lower temperature to another body at a higher temperature without the aid of an external agency. This is a case similar to what you observe in the case of the refrigerator. In the refrigerator, the foodstuff is already at low temperature, but it has to be further cooled. So heat is absorbed from the foodstuff kept inside the refrigerator and the heat is transferred to the external environment, that is another body. The temperature of the environment is higher than the temperature inside the refrigerator. In order to do this, we have to seek the help of an external agency. What is that external agency? It is the electricity. Unless the refrigerator is connected to a source of electricity, the refrigerator will not work. It cannot cool the foodstuffs kept inside it. So the second statement says about transfer of heat from a lower temperature to a higher temperature. What will happen if the temperature of the cold sink, which we have taken as T2, is equal to the temperature of the hot source, which we have taken as T1? That is, what will happen if T2 is equal to T1? Both are having the same temperature. Under such a condition, no heat can be transferred. In the case of refrigerator, when T2 is not equal to T1, work has to be done in order to get cooling effect. Work is not equal to 0. Therefore, the efficiency or the coefficient of performance cannot be infinity, although it can be greater than 1, that is greater than 100%. This also explains why a book resting on a table cannot move by itself by taking energy from the table, or the table cannot transfer energy to the book in order to make it move, because they are at the same temperature. I hope it is quite clear. As we have already stated, these two statements which state the second law of thermodynamics are negative in nature, so it cannot be proved experimentally, and moreover, there is no mathematical representation for this law. The second law does not contradict the first law. It does not say that the first law is wrong. but it only explains the first law more. I have given the heat engine, refrigerator, and heat pump as examples or applications of the first law of thermodynamics because in these machines there is interconversion of heat and work as suggested by the first law of thermodynamics. But the limitations of these gadgets is explained by the second law of thermodynamics. So some books give these gadgets as applications of second law of thermodynamics. I just wanted to refer to that. That's all. Anyway, that principle is used in transfer of heat, expansion of a gas, then diffusion, etc. I hope this video was of great use to you. If you think the video was useful, do not forget to like, share and subscribe my channel. Press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with the next important topic. Till then, bye. Take care.